Hello and welcome to a Maths with Harry lesson. In this video we're going to be looking at surds and rationalising the denominator. Now before we start looking at surds, what I want to do is quickly look at square numbers. You've probably seen square numbers before, you might have done some work with sequences on square numbers. What I'm going to do is I'm going to list the square numbers, and the reason I'm going to do that is because I'm going to introduce the square root to you. So, you've probably seen this before, but the square numbers are found by multiplying two numbers together that are the same number. So 1 times 1 gives me 1, 2 times 2 gives me 4, etc. We multiply a number by itself to get a square number. So if we start, 1 times 1 is 1, so that's our first square number. Then if we've got 2 times 2, we get 4, 3 times 3, we get 9, and then we'll have 4 times 4, which will give us 16, 5 times 5 gives us 25, 6 times 6 gives us 36, and we'll go up to 8. We'll have 49 from 7 times 7, and we will have 8 times 8 will give us 64. I'm going to put ... because the square numbers carry on. We can never find the last square number because we can carry on squaring numbers forever. So I'm going to write in grey. This number comes from 1 squared. This number comes from 2 squared and 3 squared. Next we'll have 4 squared, 5 squared, 6 squared, and you get the gist. 7 squared and 8 squared. So those are our square numbers. Now at GCSE you've probably seen the square root function. And what the square root function does is, if we were to square root a square number, so if we take the square root, looks like that, if we square root one of these red numbers here, we will get the number that we multiply by itself to give us the square number. So for example, if we square root 4, we need to find the number that multiplies by itself to give 4. So 2 times 2 gives us 4, so the square root of 4 is 2. If we look at the square root of 36, the square root of 36, we need to find the number that multiplies by itself to give 36. So we know 6 times 6, because that's 6 squared, 6 times 6 gives us 36. So the square root of 36 is 6. So that's what we do when we square root. Now, in this case, I'll write it down here. We can square root, as we just did, square numbers. And when we do that, we get an integer. So if we square root 64, we get 8. 64 and 8 are both integers. An integer is a whole number. But what happens when we square root numbers that are not square? So for example, if we square root 13, or if we square root 7, what can we do? Well, what I'm going to do is I'm going to introduce a definition. So let's have a look at a definition, and I'm going to take the definition straight from the book. So here's the definition, and I'll write it in red. If n is an integer and n is not square, so not square means it belongs in this list here, then the square root of n is called a surd. Now you probably have seen surds at GCSE before, but if we square root a non-square number, we'll get a surd. Okay, let me introduce you to some surd rules. Now again, you might have seen these before, but we'll have a look at them now. There's 3 surd rules that you need to know, and you can use them to manipulate surds. The first one is if we've got, and I'll just extend that, the square root of AB. Now remember, AB is the same as A times B. So what we're actually doing there is the square root of A times B, and it's all under 1 square root. What we can do with that is we can actually break the square root, if you like, and give the square root to both A and B. So that's the same as the square root of A multiplied by the square root of B. So if we have AB under the square root, we can kind of distribute the square root over the multiplication and get the square root of a, work out what that is, and multiply it by the square root of b. And a and b there are just integers, they're just any number. That rule works for any number. What I'm going to do is I'm going to highlight that in red. Okay, if we want to have a look at another rule, well, under the square root there we were multiplying, so we must have a rule for dividing. And I'll write that one down here. If we've got the square root of a divided by b, then you might expect what we can do with that is we can distribute the square root to the top of the fraction and the bottom of the fraction. So in other words, we can have the square root of a divided by the square root of b. So that also works as well, by the way, if we wrote it like that, because a fraction is just the same as dividing. So if we've got division under the square root, we can do the square root of a divided by the square root of b. That's another rule, so we'll highlight that one in red as well. And then we will move on to the third rule. Now, the third rule is not actually in the book that I'm using here, but it's quite an important little thing that you might need to know to help you. And what it is if we've got the square root of the same number being multiplied together. So if we've got the square root of a and we're multiplying that by the square root of a. Now, what that will give us is that will give us a. So we will just get the number that is under the square root. And in this case, a is the same. A here is the same as this a. Now, the reason that works is because we can think about it in terms of this rule here. Well, we know we can kind of work backwards. Let's do a little proof of this one, just so you know where that comes from. If we do a little proof, we can start with this, and in this case here, our b is a. So we know that the square root of a times the square root of a, if we work backwards on this first rule, we can bring the two a's under the same square root and we can just multiply. So we can have the square root of a times a. But we know what a times a is. We can bring those two a's together and write it as a squared. So that's going to give us the square root of a squared. Now, what we're doing there is we're squaring a, and then we are square rooting a. And you might know that if we square something and then square root it, we just get back to what we started with, because the square root is the inverse of squaring. If we do something to the number and that thing we do is square it, we then square root, we'll just get back to, in this case, a. So what that is equal to, is, go back to the pen, a. But we can also think about that in terms of index laws. Remember, the square root of a is the same as a to the half. So the square root of a squared is the same as a squared all to the half. And then remember, we can just multiply those two indexes together across the bracket. And that's a rule that we learned in a previous video. So we can multiply those together, and 2 times a half just gives us 1. So we'll have a to the 1, and then that's just a. So that kind of proves this rule here. So whenever you've got the square root of a and you're multiplying it by itself, the square root of a, you just get what's under the square root. Alright, let's have a look at some examples. So you can press pause and have a go if you want to, and then we'll go through the answers. Alright, hopefully you managed to have a go at those. All we needed to do was simplify the following surds. And the way we do that, we simplify using the 3 rules that we've just got. So what we need to think about is, we need to think about what can we actually do to the number under the surd. Now, if we think about 16, we can split that up into 4 times 4, because we know what 16 is. And actually, this one's quite easy because 16 is a square number. So we just need to find the number that multiplies by itself to give us 16. So let's go through it as in we were using the first rule here, because what we're doing is we're doing a multiplication. So I'm going to split the 16 up into 4 times 4. because we know what 16 is. Now 16 is a square number, so we can just write down the answer, but I'm going to do it in terms of the rule. So the square root of 16 we can write as 4 times 4 square rooted, and then we can distribute the square root of 4 times the square root of 4, and then we've got the third rule there, and that is just 4. So the square root of 16 is 4. Now we can also think about that, like I said, as 16 is a square number. What number multiplies by itself to give us 16? Well, that's 4. Okay, the other ones are a little bit different. Now, if you had a go at these, you might have done them at GCSE, so you might have been able to do them. But what we need to do is simplify. And the way we simplify is we take out the biggest square number under the surd. So the square root of 12, we need to split that up into some multiplication. Now the biggest square number that goes into 12 is 4. And we can think about our square numbers like at the start here. 1, 2, 3, okay, 4 goes into 12, and that's the biggest because we know that 4 will give us 16 when we square it, and 4 is a square number itself. And then no other numbers here actually go into 12. So the biggest square number is 4. So what I'm going to do is I'm going to split that 12 up into 4 times something. So the square roots will stay, and then we know what 12, well, it's 4 times what? The what is 3. So 4 times 3. And then what we can do is we can just use the rule up here, this first rule again, to distribute the square root over the multiplication. So the square root of a times the square root of b. And here, a and b, well, a is 4 and b is 3. So what that will be equal to is the square root of 4 multiplied by the square root of 3. Now the reason I want to split 12 up into the biggest square number times something else is because now that can simplify. We could follow this pattern here, but we recognise that 4 is a square number, so all we need to do is just square root 4, and that will give us an integer. What number multiplies by itself to give us 4? Well, that's 2. So all we need to write that down is 2 times root 3. Now I'm going to go back up to the definition of a surd. If n is an integer, and here we're dealing with, well, 2 times root 3, so I'm thinking about simplifying root 3. If n is an integer and n is not square, then root n is called a surd. Well, 3 is not a square number because we listed them here, and 3 is not in this list. So we're not able to simplify 3. And the reason we can't simplify 3 is because 3 is prime. Only itself and 1 go into 3, so we're not going to be able to get out a square number of 3. A square number, sorry, that goes into 3. Okay, so all we can do is just remove the square there to give us 2 root 3. And that is our final answer, because like I said, we can't do anything with the 3 because it's prime. Okay, let's have a look at root 20. So again, we're going to follow the exact same process, and we're going to take out the biggest square number. You don't have to take out the biggest square number straight away. You can do it slowly. You could take out a factor of 2 and have 2 times 10, and then what square number can go into 10. But what I'm going to do is I'm just going to do it straight away. So I'm going to again take out the square number 4. So we're going to have the square root of 4 times what gives me 20? Well, 4 times 5 will give me 20, so under the square root we'll have 4 times 5. Then we can do the exact same thing. What we can do is we can distribute the square root. So square root of 4 times the square root of 5, and then we know what the square root of 4 is. That's 2 and times root 5. And again, just like 3 here, 5 is prime, so we're not going to be able to take out a factor that is a square root. We're not going to be able to have a square root times something, a square number times something gives us 5. That's not going to work. So we're just going to leave that as the square root of 5. So again, we're just going to have 2 root 5. And that will be our final answer. Now, when we actually do this on a calculator, we just get 2 root 5 straight away. If you put the square root of 20 in, you will get 2 root 5. But you need to be able to manipulate these in big questions at A level. Okay, let's have a look at 5 root 6. So for D, we need to think about, can we simplify here root 6. Well, if you were to put that in a calculator, let's actually grab a calculator and see that. The square root of 6, if you press equals on that, you might be able to see, and I think it's too dark, but what we get is the square root of 6 back. And the reason for that is because there is no square number that goes into 6. We can split 6 up into, and we'll just go back to the pen, 1 times 6 gives us 6, 2 times 3 gives us 6, and those are the factors of 6. We can't get any other multiplication there that will give us 6. And of course they have to be integers. We can get fractions, but the integers, the factors of 6, are just those. So we can't split up 6 in any way. So the answer to that one is just going to be 5 root 6. And if you put that into a calculator, you'll just get 5 root 6 back. There's no simplification that can be done there. So we'll highlight that in yellow. Okay, let's have a look at E here. Well, we've already done in part B what root 12 gives us, and root 12 is 2 root 3. And again, you can check that on a calculator. If you put in 2 root 3 or root 12 on your calculator, you'll get back 2 root 3 because that's in the simplest form. Okay, so I'm going to write that in blue as 2 root 3 plus 5 root 27. And then I need to think the biggest square number that goes into 27. And again, the reason we take a square number is so that we can simplify and square root the square number. Now we can think 27 is 9 times 3. 9 is the biggest square number that goes into 27. And so what we can do is have 2 root 3 plus 5 times the square root of 9 times 3. And then we can use the first rule just to distribute the square root over the multiplication. So we'll have 2 root 3 plus 5, and then we're going to introduce brackets here because we're multiplying 5 by the whole of the square root. So when we distribute the square root like that, we need to multiply both of those by 5. And then I'm just going to come across here. We should have enough room. We'll have 2 root 3. And then the square root of 9, well, we know what the square root of 9 is. If we look at our square numbers here, what number multiplies by itself to give us 9? Well, that's 3. So the square root of 9 is 3. So we can have plus 5 times 3, and then multiply that by root 3. Okay, and then all we need to do is just simplify the brackets. So we will have 2 root 3 plus, and then all we've got is, well, we can actually get rid of that multiplication sign there to give us 3 root 3. And then all we need to do is just multiply the numbers. We can't do anything with the root 3, but we can multiply the numbers and we will get 15 root 3. And then when we add them, we will get 17 root 3. And that will be our final answer. All right, let's have a look at the next one. So F, and I'm just going to make that a little bit smaller, like that, and we'll just put it down there. Okay, F might have been a little bit tricky, and I have worked this one out before the video. You need to split this up into, again, take the biggest square number out, but you might not see this straight away. So what we can do is we can observe that 294 is an even number. So we can take out a factor of 2, and it's 2 times 147. Now what I'm going to notice is that 147 is divisible by 3. And the reason we can see that is because a little trick. To test a number is divisible by 3, we can just add up all the digits. 7 plus 4 gives us 11, plus 1 gives us 12, and then 12 is divisible by 3, so we know that 147 is divisible by 3. So I'm going to take a factor of 3 out of here, and it actually works really, really nicely. We will have the square root of 2 times 3 times 49. And now we can see why I've done that. I didn't realise from just looking at 294, you might, I don't know, but I didn't realise that 49 goes into 294, and you're probably not going to spot that. So you can do it quite gradually. You can take out a factor of 2, then can you take out a 3, etc. And we took out 2 and 3, and now we've got this multiplied by 49 here. And that's really, really useful, because now what we can do is we can split up the square root. We've got 3 things under the square root, but that doesn't matter. We can still use the first rule here to distribute the square roots over the multiplication to get the individual square roots all multiplied together. So when we do that, we have the square root of 2 times the square root of 3 times the square root of 49. And we know what the square root of 49 is. Well, the square root of 49 is 7, because 7 times 7 gives us 49. So we can write that as root 2 times root 3 times 7, because 7 times 7 is 49. So then what we can do is think, right, well, can we simplify the square root of 2? And can we simplify the square root of 3? No, we can't, because we can't take a square number out of 2 or 3. So all I'm actually going to do is write that as 7 root 6. And we did that by working backwards on the first rule. We can put it all under the square roots, and we can have 2 times 3, and that gives us 6. So 7 root 3 should be our answer. And again, I'm going to check that on a calculator. You can do it if you've got one. The square root of 294 gives us 7 root 6, which is exactly what we had there. So hopefully you had a go at that. Just to kind of summarise, whenever you're asked to simplify surds, at A level you're not really asked to do that in a single question. It's more in a bigger question, and you might have to give your answer as a simplest form. You've done some big question, you've got a surd, okay, you need to simplify that surd. So you need to be able to do this. And to summarise, we just want to take out the biggest square number that we possibly can do. So biggest square number of 12, well, it's 4 times 3. 4 is the biggest square number, and then we can simplify. Of course, here, like I said though, we can do it gradually. We didn't know that 49 went into it, so we did it quite simply. We did the 2, we did the 3, and then we did the 49. Okay, right, let's have a look at question 3 and, or question 2 and question 3. Press pause and have a go if you want to. These are, well, expanding the brackets. You should know how to expand brackets, and then we need to simplify our answers. Hopefully you had a go at that. If you did, let's work through the answers. So all we need to do is we need to expand and then simplify. So here all we've got is a single bracket multiplied by some term out the front. So all we need to do is multiply the term out the front with each term inside the bracket. And we'll just make that, why is that not wanting to go into an arrow? There we go. We'll make that an arrow, and then all we're going to do is we're going to multiply along those arrows. So all we're going to do is we're going to do root 2 times the 5. So we'll have 5 times root 2. And I always like to write my integer first. We did do root 2 times 5, but we can write it the other way, and I like to write the integer first. The reason I do that is because if I had root 2 times 5, I might get mistaken what I'm square rooting. I'm not doing that, I'm doing the root 2 squared and then multiplying it by 5. But if I write the 5 out the front first, we shouldn't get mixed up. Okay, so 5 times root 2, and then I'm going to have plus, because I'm going to add it, but actually it's a negative here. So what we need is root 2 times minus root 3. And you don't have to do it in such big steps here. I'm just showing you the working out. So we can get rid of the sign there. We can just have 5 root 2. And then we can have minus root 6. And again, it's root 6 using the first rule. If we've got 2 numbers like this, we're square rooting each one, we can bring them under 1 square root. And then multiplying the numbers, 2 times 3 gives us a 6, and the minus makes that a minus there. Okay, and then can we do any simplification with that? No, we can't, because root 2 we can't simplify, and root 6 we can't simplify. So that is exactly what we need as our final answer. Alright, look at B, we've got double brackets here, so what we need to do is we need to multiply everything in the first term, and these arrows are not going well, everything in the first term by everything in the second term, or second bracket. So we're going to multiply the 2 by the 5 and the root 3, and then the minus root 3 by the 5 and the root 3. So let's do the 2 first. We're going to get this, and I'll do it here. We'll have 2 times 5, from the 2 times the 5, the first arrow, and then plus the 2 times the root 3. And then I'm going to add this on. We will have 5 times minus root 3, and I'll just move this up slightly. And then we will add, and we're going to have minus root 3 times root 3. Okay, so all I was doing there was just expanding the brackets and multiplying every term in the first by every term in the second. Okay, so then we can simplify. Well, 2 times 5 is 10, and then 2 root 3 will just give me 2 root 3. We don't need to write the multiplication. We'll have minus 5 root 3 for the third term, and then here we can use the third rule. Well, we've got a minus, so we know we're going to have a minus out the front. And then we've got both 3 under each square root. We've got a 3 here and a 3 here. So if we look at this rule here, we've got the same number square rooted and we're multiplying them together. So we're just going to get that number under the square root. So all we're going to have is minus from this here, and then root 3 times root 3 gives me 3. And then we can do some simplification. Well, we can bring these two together, and I'll highlight that in red. And we can bring those together. And that's just collecting like terms. We can bring the integers together to give 7, because 10 minus 3 is 7. And then we can just say, well, I've got 2 root 3, and I'm going to minus 5 root 3. So that will give me minus 3 root 3. And again, you can check that on your calculator. If you actually to put that in, you'll have 2 minus root 3 and 5 plus root 3. And what you get is 7 minus root 3, which is exactly what we had there. So your calculator is really useful to help you simplify these. Okay, question 3, you can pause and have a go if you've not done so yet, but we'll work through the answer for anyone that's had a go. So, again, what we need to do is just like in question 1, we need to take out the biggest square number from both 75 and 12. We actually know what 12 is, we did that in part B. 12 is the same as 2 root 3. So I'm going to write that down here. That's equal to root 75 minus and 2 root 3, is that right? Yes, it is. So all we need to do now is we need to simplify 75. And the biggest square number that goes into 75 is 25. 5 times 5 is 25, so 25 is a square number. And I can put 25 under the square root, and then I need it to be 75, so I need to multiply it by 3. Because 25 times 1, well, that's 25. Multiply it by 2 is 50, and then multiply it by 3 is 75. And that's the biggest square number. So now what we can do is, well, we can distribute, and we're going to need that minus 2 root 3. We can distribute the square root of 25 times the square root of 3 minus 2 root 3. And then the square root of 25, what we know is 5, so I can write that as 5 root 3 minus 2 root 3, and that's just going to give me, well, 5, and then I'm taking another 2, so that's going to give me 3 root 3. And again, you can actually check that in your calculator. So the square root of 75 minus the square root of 12 does in fact give us 3 root 3. And we can't simplify that any further because we can't take out a square root from 3, so we're just going to leave it as 3 root 3. Okay, so that's everything that I've got on Surds. We're now going to have a look at rationalising the denominator. So I've written down here, what do I actually mean by rationalising the denominator? What can we use this for? We use this to, and I'll write this in red, we remove the surds from the denominator. So what we want to do is a simplified fraction in its simplest form, if it's involving surds, is no surds on the bottom. We want the surds to be on the numerator. We want to get rid of any surds on the denominator. And just to refresh, if we've got a fraction, let's say a over b, a is the numerator, I think I spelt that right, and b is the denominator. Okay, so there are three cases to rationalising the denominator. There's kind of three types of fractions that we can have. The first case is if we've got 1 over the square root, and in fact I'm going to write that like that, 1 over the square root of a. Now we can see we need to rationalise that fraction because we need to remove the surd from the denominator. We've got a surd on the denominator here. And I've got a little arrow here because what we need to do in that case, and I'm going to write this in green, when we've got the square root, or 1 over the square root of a, we multiply by the square root of a over the square root of a. That's what we multiply by. We can't change our fraction here, but we can rationalise it by multiplying top and bottom by the square root of a, whatever's on the bottom here. Okay? Now the next case is if we've got 1 over the square root, and I'll write the square root first, we'll have a plus the square root of b. Okay, so we've got this number out the front here and we're adding some surd on. Okay, now it doesn't matter if b is in its simplest form, it doesn't matter. What we need to do in this case is we need, and I'll write it again in green, we need to multiply top and bottom, multiply by the square root of, and in fact it's just a little bit square root, isn't it? A minus the square root of b. We multiply top and bottom by a minus the square root of b. And the reason we do that is you'll see in a minute when we have a look at some examples, it cancels out the surd. It's the difference of two squares there. Okay? If, again, though, we have got 1 over, what happens if we've got a minus root b? So again, it's a little bit similar to this, but here we've got a negative. Well, you might already have done this at GCSE, or you might be able to work this out. Here we had a positive, so we multiply by a minus root b. Here we've got a minus, so what we're going to do is we're going to multiply top and bottom, and again I'll write this in green. We need a black arrow first. We need to multiply by, and we do it top and bottom so it stays the same, a plus root b over a plus root b. Okay, so here we had a negative, so what we want to do is multiply top and bottom by the positive surd, and we take the a with it. Okay, so those are the three cases. If we've got just a square root on the bottom, a plus a square root, and a minus a square root, this is what we need to multiply top and bottom by. Now, just so you know, what we're actually multiplying by is a special form of 1. We can't change what the fraction is, and the only way to not change the fraction is to multiply by 1. But because we're multiplying top and bottom by the same thing, they could actually cancel out to give us 1 over 1, which is 1. But we want to multiply by a special form of 1. So don't worry too much if you don't understand that, but that's what we need to do. We need to multiply, if we've got root a on the bottom, by that, if we've got a plus root b on the bottom, by the negative, and if we've got the negative on the bottom, we need to multiply by the positive. Okay, so here are some examples. We want to rationalise these denominators. And there's an example here of, well, there's an example of just a surd on the bottom, a positive, another positive, but we've got a 2 on the top, and here we need to do something on the bottom there. Okay, we need to do a little bit of expanding. All right, so press pause and have a go if you want to, and then we'll work through the answer. Hopefully you've paused and had a go. Don't worry if you didn't get them all, we'll work through them now. So for A, I need to multiply top and bottom by root A. Now of course we've got 1 over root A. Here we've got 1 over root 3. So I could actually write down that my A is 3 here. So I need to multiply, and I'll do this in red, top and bottom by what's on the bottom, root 3. Okay, so when we do that, I'm going to get, well, 1 times root 3 is just root 3. And on the bottom, we're going to have root 3 multiplied by root 3. Now let's go all the way back to the start of this video. Remember the first rule that we had here, or the third rule, sorry. Root A times root A just gives us A. So on the bottom, we're just going to get 3. Root 3 over 3, because we've got the same number in each square root and we're multiplying them together. So root 3 over 3 is our final answer. And that's now rationalised, because look at the denominator. There is no surd on the denominator. We started off with a surd and now we've got rid of it, and our surd is now on the numerator, which is what we want. That's a simplified form of this fraction. Okay, for B, what we need to do is, well, we need to multiply, and we'll do this in red. I need to multiply top and bottom by 9 minus root 6. And 9 minus root 6. We do the same thing to top and bottom. So then, what I'm going to have is on the top, 9 minus root 6. And on the bottom, I'm going to have 9 plus root 6 and 9 minus root 6. And then this on the bottom here is the difference of 2 squares. And that's why we multiply by the different sign. Because all we can do is we can get that as equal to 9 minus root 6 divided by, when we expand this, it's the difference of 2 squares. So it's just going to be 9 squared plus the square root of 6 squared. And of course it's a minus here, so it's going to be a minus root 6 squared. Okay, so what we're going to have is, well, 9 times 9 is 81, and then we're going to take away, because it's a negative, root 6 squared, which is just 6. And then that's going to give me 9 minus root 6 divided by 81 take away 6, which is 75. Okay, and that's what we should get. And I'm just checking my answer there. 9 minus root 6 divided by 75 is our final answer. We could actually write that, and I'll do it just in grey down here. 9 minus root 6 divided by 75, we could write that as 9 over 75 minus root 6 over 75. The only reason I'd do that is if I needed to, or if this 9 and 75 could simplify, but it can't, so I'm just going to leave it as 9 minus root 6 all over 75. Okay, let's have a look at C. I'm going to multiply top and bottom, and I'll do it in red again, by, well, I'm going to have 3 minus root 2 over 3 minus root 2. Okay, now don't be alarmed that we've got this 2 on the top here. Here we all had 1s, and in our cases here we had 1s. It doesn't actually have to be a 1, that was just the form of the fraction. So what I'm going to do on the top is, well, I'm going to have, and we'll write it up here, 2 multiplied by 3 minus root 2. And we need brackets here because we're multiplying 2 by everything inside the brackets. And then I'm going to divide that by 3 plus root 2 times 3 minus root 2. And again, it's the difference, it's the difference of 2 squares. So I'm just going to have, and we'll do this in green, 3 squared minus, because it's a minus here, because it's the difference of 2 squares, minus root 2 squared, which is just 2. So let's carry on. So we're going to have 6 minus, and I'm going to have 2 times root 2, which is just 2 root 2, divided by 3 times 3, which is 9, and root 2 squared, which is 2, so minus 2. And that will give me 6 minus 2 root 2 all over 7. Okay, and we can just check we've done that right. 2 times the 3 gives the 6. 2 times minus root 2 is 2 root 2. And then 3 squared minus root 2 squared. And that then gives us 7 on the bottom. And again, you can check this in your calculator. If you've got one, don't be afraid to check it in your calculator. And 6 minus root 2 over 7 is the correct answer. All right, let's have a look at D. We'll move D down a little bit, so it's just down here. D, what we need to do is, well, first of all, it's in a little bit of a strange form. We've got this squared and we're squaring the brackets. It's not in any of these 3 cases here. So what I'm going to do is I'm going to expand the bracket. So when I do that, I'll get 1 over, well, what we're doing is 1 minus root 7 times 1 minus root 7. And then let's expand those brackets. I'm going to do 1 times everything. So I'll have 1 minus root 7. And then I'm going to do minus root 7 times everything. So we'll have minus root 7 and then plus, because we've got a minus times a minus, and then root 7 times root 7 using the rule is 7. And then I can simplify the bottom to give me 1 over, and I'm just going to move that over a little bit. We'll have 1 over 8 minus 2 root 7, because we can add the 1 and the 7 together to give me 8, and then we can minus those to give me minus 2 root 7. Now what I need to do is I need to multiply top and bottom by 8 plus 2 root 7 divided by 8 plus 2 root 7. Okay, top and bottom by 8 plus 2 root 7, because we've got a plus here because it's a negative in our fraction. And when we do that, well, I'm going to have 8 plus 2 root 7 divided by, and again it's the difference of 2 squares, 8 minus 2 root 7, there we go, and 8 plus 2 root 7. And then I'm going to have, well, it's the difference of 2 squares, so 8 squared minus, remember, because it's the difference of 2 squares, minus 2 root 7 all squared. So I'm going to have 8 plus 2 root 7 divided by 8 times 8 is 64, and then 2 root 7 all squared, and I'll write this just at the bottom here, 2 root 7 all squared. Well, I can distribute, remember from our distributive index law, distribute the 2 to each part there. So I'll do that in grey. We'll have 2 squared multiplied by root 7 squared, which is 4 times 7. And then we can work that out as 30, hang on a minute, 7 times 4. My brain has gone blank. 7, 14, 21, 28. There we go. Okay, so what I'm going to do is I'm then going to minus 28 there, and I'm just going to rub out what I did. I'll make it smaller so that you can still see it. There we go. Perfect. And we're going to have 8 plus 2 root 7, and then if you didn't have a calculator, hopefully you'd managed to do this. 64 minus 28, we could take off the 20 to give us 44, and then we could take off the 8 to give us 36. And then we can simplify each of these by 2, because we can see in the red here, those 3 numbers are divisible by 2. So I can divide all of them by 2 to give me 4 plus root 7, and then 36 divided by 2 is 18. And that should be my final answer. Again, we can check that on a calculator. So 1 over 1 minus root 7 all squared does give me 4 plus root 7 over 18. So all the quick mental maths there was perfect. All right, there is an extra question here if you want to have a go. Press pause and have a go, and then you can discuss the answer to that one in the comments.